Hi there guys, I'm Chris Bowden and you're not!
And I'm Paul Kidwell.
Welcome to the Geek Group once again, deep under Cayenne Mountain here in the basement of the Science Building, where we are continuing our series on Electronics 101. And we're going to the next level here.
Yes, we are.
We've got a beautiful digital storage oscilloscope.
Yes, we do.
This is your baby. This is like your sacred oscope.
This is my toy.
Now this is the level of oscilloscope that any kid today, like a high school, college kid that's getting serious into electronics, this is where they want to be.
This will get you everything you need below microwaves.
Okay.
It's a Tektronix 2230. It's a 100 megahertz scope.
Okay.
And it's 2-channel.
And it's not a fortune. This is
not a fortune. It's $300 to $400. Buy it now price on eBay.
Okay.
Including shipping.
So that's not so bad.
Not at all.
Well, let's take a look inside here. We've got, pop the lid. Now I'm going to move this over because it's got a screen. Okay, we've seen the screen. We want to look at the controls right now.
Yes.
So we'll just take a look at those.
All
now,
right.
There's a lot of buttons on there.
There's a lot. We'll get it going.
Okay.
You have your focus and intensity over here.
I actually heard a fan come on.
Yes, it has a fan. And let's see. Channel 1, Channel 2, and your time settings and your trigger settings over here.
Now, hang on a second, because this is neat. I looked at the screen over here, which it looks like it's flickering on a thing, but that's because the monitor is interlaced and whatnot. But the image here is actually really steady. But there's like numbers and stuff on the display. This is like a computer. Yeah, this isn't like...
I'm going to take one channel 2 off.
Now, is this like you're actually controlling the thing in real time, or what? Because...
Yes. Okay. I set the trigger on line, so we got a continuous line. You'll notice there isn't a calibration loop on this one.
Okay. Well, here let's look back at it. You know what this means, though, that's flickering. The other one wasn't flickering. All the scopes you've looked at before now weren't flickering. That one flickers, so that tells me that is a refresh rostered image.
This is a storage scope.
Okay.
Now, if I put it to non-store, we go back to like the other scope. Let's get the intensity up.
It still flickers down here. So it's probably not a rastered image. It's probably a vector drawn image.
It's still
I'm pretty sure that.
It's still a vector drawn image.
But it's refreshed. It's not. It doesn't have the high speed, because look down here. It still flashes.
Well,
so
it's
this
flashing.
is different.
It's flashing for us too.
The 50 isn't though. Look there. Look on the blocking marker. See it flash? Here it doesn't flash.
Your electron beam is going to refresh the phosphors, but it doesn't have to refresh them continuously.
Okay, so let's take a look. It just caught my attention. Now there's a lot of knobs on here.
Yes, there are.
This is cool.
All right, now let's see. We have the same AC/DC ground setting for the 2 channels, so you can set it to ground and then use your position, which you've got a position set right here for 0.
I'm going to grab a flashlight and get you a little more light in there so that you can...
I don't know if that's
that didn't help
helpful.
So much.
No, it doesn't. So you got a position. You got selecting whether you're looking at channel 1, channel 2, or both. That's where you're doing the alternating thing.
Now, what's that little...
That's your calibration thing. It's the loop on the other one. It's just a touch point on this one.
Okay.
You'll notice it says 0.5 volt square wave.
I was pretty sure it was a calibration thing. It was different.
We got a ground point here. It's for a banana plug.
Okay.
It doesn't have the
you just
thumb
stick
screw.
It in there.
Exactly. Let's see. Position left and right. Let's see. Your timing setting is here. This set of buttons up here control this. We need the buttons and the display on it.
You need me to zoom out a little bit? Okay.
Yeah.
Yeah, well, let's get a look at them before we, just so people understand what they are. I see things like memory and acquisition and cursors.
This selects whether you're doing storage or not. When it's out, you're just like the other scope where it's, you're looking at the trace as it's going. The store, it actually will capture your data and then display your image. We'll get into that a little bit more, but you can set whether you're looking at the data before or after, pre or post trigger.
Okay.
you can set how much data you're collecting, either 1,000 data points or 4,000. If you select 4,000, you're actually putting more than what's displayed on the screen, so you can like scroll over. Okay, this is a cursor control. There's a little cursor. It's like, we'll show it in a second, but you can see move the cursor around.
Okay.
We can do fun things with that,
That's
which
cute.
we'll get into in a minute or two. All right. Add chop alternate. That's where on alternate, when you're displaying both channels, that's where it does, one then the other, back
What's
and forth.
chop?
Chop is where one channel clips the other. Add is where the two channels get added together.
Okay,
if you
so
got,
chop, add is x plus y, chop is x minus y.
basically, yes.
Okay.
All right. Generally, I'll use alternate all the time. Add sometimes if I got things happening on different channels at the same time and I can't do a one then the other sort of thing. I got to see them both at the same time. If I know there's a square wave in there, I can put add and it'll put the other wave on top of it, and I can
And
just
when you see the
mentally
little square wave pop on,
I
you know where
can
you're
mentally pull that square wave out and look at what the rest of the waveform looks like and know that the rest of it is from channel 2.
at. Okay.
It's mostly used for like triggering, when I want it to trigger on the one channel. You can also use, you got external triggering from here. This was also on the other scope. And these switches here set how you're going to use this. I got a little setting here for external, and then it's coupling on this, either AC, DC. There's a DC times 10. So this is if you have a signal that you want to use for the trigger, but you want to look at something else.
That's actually DC divided by 10.
Divided by 10? That is a divider. Okay. But line or internal and channel 1. Internal channel 1 is the same as channel 1 setting on the other scope. Line is the same as the line setting on the other scope. So I'm usually either doing line to do the initial find the waveform, and then I set to channel 1, which is the channel I normally use, and then I play around with the trigger level here. You can see I'm getting a little light blinking like on the other
Yeah,
one.
I see the light come on.
And the other one, you hit the center of the button. This one, you got a slope over here. When it's in, you're looking for a negative slope. When it's out, you're looking for a positive slope.
So if you, even like from our previous video where you learned the basics of what the controls do, once you've got that down, even on a much older scope, just by looking at the pictures and reading the writing, you can get a pretty good idea what does what.
The majority of the controls are the same as on the original scopes. The very simple, like Heathkit scopes that have like 2 knobs and a couple of connections on it, and that's it, have the same sort of features as what this does.
Okay. Well, we'll zoom out a little here, and we'll take a look where we can see the whole system here.
Wait, can we pause for a second?
All right, now we can see everything, and people have, they may not be able to read all the writing and stuff, but they'll be able to know what the buttons are and whatnot.
And I'll say what I'm hitting when I'm doing it.
Okay. So that's the cursor thing right there.
Yes. Need to talk about probes a little bit. These are Tektronix times 10 probes. And
Now we've got divide by 10 there, and these are times 10.
That's for timing. This is for voltage. This is a 150 megahertz probe, which is better than what we actually need for this
What
scope.
does that mean, 150 megahertz probe?
That's the maximum frequency that it can actually pick up.
Because of the capacitance of the probe and the lead and all that?
Exactly. It's a 10 mega ohm, 11.8 picofarad
Show 'em.
probe.
Put it up here, show 'em.
And it's a model P6109 probe. And you can get, I checked eBay, you can get a pair of these for like 20 bucks.
Cool.
All right, so the probes, and the times 10 bit, if you look, there's a little nib sticking out right there.
Okay.
And that catches the ring on the outside here.
The way, like, this ring down here?
Yes.
Oh, okay.
So that tells the scope that you got a times 10 probe. This.
So it's a third conductor.
Yes. This is just a standard probe. It's got a times 10 on here, but this isn't a Tektronix probe. So it doesn't have the third conductor, and there's a little calibration thing.
Yeah, I was wondering, what's
as
the thing
well.
down in here?
But that one auto-calibrates effectively. This one is not a Tektronix. This is probably a $5 probe. All right, and it's got a real nice little hooky thing on the
Okay,
end.
now I notice on these, I've got the probe and I've got a little hook
You
thing.
got a ground
Now,
clamp.
okay, so this here connects to the outer conductor, the ground,
Yes,
not the pin.
shield, not the pin.
But the shield.
Right.
That's this.
Correct.
And then this is the center conductor.
The center conductor is there. And
Okay.
the gauge of the wire...
Now, where does
in-
this connect to? The times 10?
It's there's electronics buried inside this thing.
Oh,
here.
okay.
All right. The gauge of the wire inside here, the insulation, it's mostly insulation. You have like a hair, like maybe 44 gauge or even finer than that going down the middle of this, and that's your actual signal.
Why is it so tiny?
You're not really affecting or not supposed to affect the circuit that you're dealing with, and
So
they
it-
got it all, trying to cut the capacitance and inductance
Okay.
on this down as much as possible, so you're not affecting.
So this is some
What you're
serious
dealing with.
engineered wire
Yes.
happening here. Okay.
Now, I'm going to clip up here just so we can put something on there and play around a little bit.
You just getting a signal generator?
I'm just getting the signal generator, and the time is set way high. And we just want one channel. Okay, so
I'm gonna get out of your way and let you push knobs there.
all
'Cause
right.
I don't know what you're doing, and I'm trying to learn.
Okay, so we got a nice little sine wave going here, and we have storage turned on. Now, before, where I did the single trace bit,
Yeah, I remember that.
well, if I do, there's a setting over here for single sweep.
Okay.
And if I hit that, I don't have the trigger set. Or are we online? No, we're on internal. There it is.
Ta-da!
Now, it captured that single trace. I can unplug now. Oh, well, I got another trigger when I unplugged. But
So we're not looking at the same thing redrawn over and over. That's one trace.
I'm disconnected now.
Okay.
All right, so I can.
And we still have the picture.
Yeah, so I can capture it and I can do things with it. Now, remember before where I looked at where the zero cross was?
Yeah.
And then looked at the zero cross again?
Yeah.
Well, we have cursors. You can see one moving around right there.
There's actually three of them. There's one over here
That
and one back
little
here.
T is the actual trigger point.
Okay.
So I'm going to put a cursor right on the zero cross line. Right there. I want to hit the button, and that switches me over to the other cursor. So I go to where it comes back and crosses the 0 point. So I got one complete wave. And it's telling me up here, delta t, change in time, is 10.94 milliseconds.
Okay, so that's the time from there to there.
So the duration of one wavelength is 0.01094.
Okay.
Hit 1 over x on your calculator, and that'll tell you the frequency that our signal generator is putting out.
Okay.
This is a much higher precision device than the other oscilloscope is. It
Yeah,
allows us to do a lot better measurements and figure things out.
How accurate is it? Like, is
I-
that a number you can count on?
It's close enough for everything I've ever done.
Okay.
Okay?
Now, what's up here? We've got
All right.
delta V.
Okay, V1, it's showing you the voltage at your cursor. Like at the top of the wave, it's seeing 11 volts. And at the bottom of the wave, we're seeing 10 volts. So we have a DC offset of, what, a 10 volt
21
DC
volts.
off? No, a 10 volt DC, it's not negative. Oh, yes, it is. We're at negative 10 volts there.
How do we know we're negative? Because we're below the zero line?
We're below
or-
the zero line. You can
Okay.
see we're going, it's giving you an amplitude. There's zero.
Oh, okay.
And now I'm going
Yeah, but when you
positive.
go below, it doesn't say, it doesn't,
It doesn't flip the sign.
yeah, okay.
Actually, I'm going to, okay. Delta V, change in voltage. I got the first cursor at
Zero.
So it's showing you the amplitude change from where your other cursor is. So if I
Okay.
put this there, now I can do a peak-to-peak measurement.
And 21 volts.
And 20.8?
21. Ha!
21, there you go. All right, so again, change in volts, change in time from one cursor to the next.
Okay.
Down here, it's displaying the scale I'm on. I'm on a 5-volt scale, and if you look right here, it's got a little 1x box, 0.5, and a 10x probe, 5. I'm using the 10x probe, so this is the voltage per grid.
Okay.
All right, and 2 milliseconds is the setting on our little time gauge here.
That's 2 milliseconds per division?
Per grid, yes.
I like this where it tells you things and it's much more accurate and it's not,
You don't have to sit there.
This isn't fuzzy like the other one.
Yeah,
This is,
there I've set the cursors on 2 grids going left and right,
Yeah.
and it's 2 milliseconds. And if I go from, on the vertical scale, you're seeing, well, it's either 5.2 or 4.8. This is digital, so it took discrete samples.
Okay.
All right, so there you're seeing your 1 grid is 5 volts.
Okay. This is really cool. See, I've been around oscilloscopes for years. I've never gotten to really get into them. I've never gotten to, I've never had a need for them. I deal with big stuff.
Yes.
So I don't get to play with the little stuff, and this is really cool. It's nice to finally learn this stuff.
Mm-hmm.
It's neat to make a video that I get to learn something watching. So,
That's unusual.
Cool. Yeah, it's nice.
Mm-hmm. All right, now we can use this to do some other things. I don't know if it'll focus right off if I just throw it up here.
Yeah, this is where we get into the really cool stuff. Because I've gotten to do audio stuff on an oscilloscope before, but I've never gotten to do like digital signaling stuff.
We have blinking lights.
Yay!
Yes. Now
these are just for people that don't know. These are the blinking lights from the Geek 3 LED project. This is the original controller board for that.
okay, I'm going to try and just hand hold this out here. Let's see. I'm going to want.
Well, here, let's set that down on the table, and he can zoom in on that with one camera, and then we can see that over there, and then because we've got the overhead camera for this.
I'm going to set
that
up
way
a
we
couple
can-
of things here.
What's the noise here?
It's in storage, so it did a single sweep and captured a little bit of noise in
Okay,
there.
I'm going to move some stuff out of the way.
Okay, we're not going to need this anymore.
Not at
so
all?
You can
All
get
right,
rid
so I
of
can
that.
unplug that.
And there's a power cord that'll unplug.
Yeah,
on-
give me
on
just a
the
second.
back.
I'll get this out of the way. I'm going to turn it off. It's off. Paul, cameraman's talking to you here.
All right.
Huh? Just talk. Everybody in America knows you're here. It's okay.
Pull it out towards you. Okay, let's get rid of probes and more probes.
We're trying to be professional, but I think we all know better. Come on, it's us.
Okay. So I got a little power supply there.
Yeah,
I'm gonna set this-
little power supply. We're not going to talk about where you stole the power supply from.
Pick.
Hey,
Okay, I'm setting it
check
on
my
line
choice.
so we're getting a continuous signal going across here.
Okay.
And I'm going to play around with the position. I'm going to set the 0 way down here because we're dealing with DC volts, so all we're going to see is DC power coming out of this thing.
Okay.
And the time we're going to have to play with based on what we're looking at. I'm not going to worry about the ground clip all that much, but what's going on here for our blinking light demonstration is this here is a Rabbit processor board, and it's got software in it that is sending out a bit stream that's being captured by a string of shift registers in here. There's 10 chips, and it's an 8 wide shift register, so it's serial in, parallel out, 8 bits out for each one. So we got 80 lights total blinking around here. And going in here, we have the clock line that's pulsing to pulse the data in. You have the data that's being sent out. So every time you see a light transition from one to the next, it's sent out the complete
For the whole picture.
for the whole
yeah.
thing. It's sent out
And
80 bits, 80 clocks.
And
worth
it's
of
it's
data.
doing it a lot faster than the people at home are seeing because I'm looking on the monitor there and it's chopping it up.
aliasing.
Yeah,
It's aliasing pretty bad. But
it's actually moving
if
faster.
we had my PC down here, we could hook up to this and I could play with the software and make it move at whatever speed or put out different patterns. I had it set up as a clock for a while.
Yeah, with the counting in binary, I remember
Yes.
that. It was really cool.
But anyhow, what I'm going to do is I'm going to probe the control lines that are going to this board. And I think the N ones are power and ground, and I don't even remember.
Now, do I need to hit
Not
toggle
yet.
something
I
to get
just
this to
I
capture?
just need to.
Now, do you need to connect the ground hook on that
I
over there?
shouldn't need to.
Oh, wow.
Okay, I'm going to put it on. Oh, I'm online. That's why. Let's go internal. And give me a flash. Oh, normal? I was on single sweep. No wonder it wasn't working. Okay, the fuzz is probably because of our ground not being there.
Well, let's do it, Ray. Let's teach
Let me
people how to
get
do
a-
this by the book.
Okay. I need to find a good ground to clip to. There's my ground line. I have a little issue with length of probe here too. You need to clip in close to your ground, or close to your signal as possible to ground your probe.
You can just look right there and see the screen if you
Oh,
see
you're
the
right.
screen.
I didn't.
Hey,
Okay,
stuff.
that is going to be the clock.
That's the clock. Now, I'm guessing I'm looking at a really fast stream of square waves.
You are. And I'm keep going. It's still looking like fuzz down there.
I'm starting to see some division now. All right,
There you go.
Now you've gone really big.
All right. Okay, there basically is the clock pulse that we use to toggle the data.
Now it's going low. Like it's
Yes.
almost always high. It
I'm
goes
going
low
to,
for the clock
let me
pulse.
do this. Come on, give me
Oh, it's gone now.
a single sweep. It's still there. It's like I can't quite see my controls.
What are you looking for?
Internal source, channel 1. We're toggling nicely. Give me a single sweep. There we go. All right. There. Now, I can let go of this and come back here. It's stored what we're dealing with. Now, the reason why you're seeing negative is it's inverse logic. A 0 is actually your high voltage, and a logical 1 is ground.
Okay.
There's a lot of things for controllers do that. It has to do with the type of transistor you use to turn things on and off.
Okay.
But I'm going to, I think we're actually working at 3.3 volts for this processor. I'm going to get a slightly bigger wave. If I can, give me a single trace. All right. At this speed, it has to build up an image. There, that's better. There. See, it's building up an image over time.
So it's adding on to the
It's
previous
adding on.
store?
You're seeing some extra lines come in.
Yeah.
This is the one trigger that's actually happening. Sometimes this pulse is at a different location because the timing is a little different. Here. There. Okay. Now, with our cursor, I can go in and where'd it go? I want to catch it right at the start where it's at the top there. There. And then I want to pick up the other side of the top here. There. So that negative going pulse is 1.25 microseconds in duration.
Very, very short.
Very, very short. And the time between the negative edge on one pulse and the negative edge on the next, I can go down here. There is 7.22 microseconds. So it takes 7.22 microseconds to get 1 bit of data from the processor to the light shift register. All right, now,
Okay.
there's only one light on at any given time.
Yeah, but it's
So-
not just saying turn this light on. It's saying turn 1 off, 2 off, 3 off, 4 off, 5 off, turn
it's
7 on,
giving
8 off. It's telling each one separately.
It's giving 80 different pieces of information.
And they're not 1 bit long. They're
No, each light is 1 bit.
So it's
So
just sending
I
them as
throw-
a stream of bits, and it knows the 80th bit is the 80th light, and it counts them out?
Exactly.
Okay.
Now, there's other signals on here which we can pick up.
I'm guessing there's like a new frame signal or,
Yes,
start
there
over
is.
signal. Hey,
But-
that looks funny. Can
Okay,
we show?
see, here's our pulses here.
Okay.
I'm going to move that up a little bit just to get it out of the
Now,
weeds.
how many data streams are there? Like, is there one wire for clock and another wire for the actual
There
data
is.
stream?
You're looking at the clock here.
Okay.
Now, one of these is, okay, one of these is the end of frame, and one of these is the data.
Okay, I'm guessing
All right.
that's end of frame because there's just one little hit
Well,
there.
there's only going to be one little hit on the data line, too. So I can tell you for certain, let's see what it looks like without the ground. Yeah, without the ground, we're nasty. I want to see if this ground is a little longer than that one.
Oh, you can change them.
Yes,
I didn't know that.
let's see how
Tab.
that works for me. I'm pretty certain, is that ground? No, that's plus. I think I can clip into our ground plane right there. No, we're still, that's
Still
not,
nasty.
it's still nasty.
Is it just a nasty signal? I'll bet you could grab the ground on top of the Ethernet connection, the shroud for it. That'd be grounded.
I don't think there's anything there that's grabbable, but we'll give it a shot.
I just touch it against there. You're on the paper. You're not going to get anything there. All kinds of
No,
noise. Yeah,
that's not.
grounded. It's icky.
It's icky. Okay. Give me 1 second to put this clip on here. There we go. Okay. That is definitely a data line. If
I
can
got
get it.
nothing.
Yeah, you do. Right
What?
there, look.
What?
When I hit it, you get a gap in the line.
A gap?
Hold
How
on.
can you have a gap? in
If you
line?
look, right there.
The little tiny
The
little.
little tiny thing, let me play around. There's the trigger.
Okay.
And I'm going to go negative edge trigger, so there. There is your data pulse.
That little tiny thing.
Now, how often do you get a data pulse? See, it flips over to peak detect, so it's got circuitry in there to detect that transition.
Okay.
And when you get another one, there, you can see it showing up there.
Yeah.
See if I can get a single trace. Give me another one. Give me another one. Yeah. My hand wigged out. There it is. I'm trying to see. There.
You can see it.
I can
Right
see
there.
it. Okay. And again, storage scope, we can let go now.
Okay.
Sometimes getting on the pin you want to be on and hold it so you get a good signal is a royal pain. But we can again take our little cursor and go over and put it right on the trigger. See, the trigger's marked by the T. I got a cursor on there. And
That's
Wait
like
for it
1
to-
pixel.
there. So I know only one light's being lit, so that one data pulse is not exactly, because, well, that's the 80 lights later, basically, but we're getting a block of data going out every 0.7 milliseconds
For all 80 lights?
for all 80 lights.
Wow.
Yeah, that's how
That's pretty cool.
that's pretty cool.
All right. So, what else do we need to cover on how to use this?
Well,
Like for basics.
for basics, we've covered basics. I mean, this is what I do a lot of, is I have a microcontroller set up and I'm playing with the circuit and I'm using my scope to probe into it to see the pulses and measure the duration of how long it takes to do something.
Okay.
It's like for software I mentioned where you toggle a bit, an output bit, and do something in software and then toggle the bit again. You can sit there and look for that bit to toggle on your scope, and you can measure, well, I know that piece of code took that long to run.
Okay. Cool. So that covers the basics.
That covers the
Okay.
basics.
So what are we going to do in the next video?
The next video, we're going to start looking into some components.
Okay.
Transformers to start with. We had someone who put in a question about a transformer, and we can use the scope, and we have an applet on the PC we can run as well to simulate things.
I don't think we have screen capture running
We don't
yet.
think we have that yet?
I'm not sure. We gotta
Well,
find out.
we can do it here.
Okay.
The idea is, well, we can do it on the screen and have it all simulated and say, okay, this is what it's supposed to be, and then you have the oscilloscope with the real thing, and you can actually do it and see it on the scope.
Okay.
And the question is, does the simulation match reality?
Does theory match practice?
Exactly.
Good luck with that.
So,
All right, well, cool. So that's our second thing on oscilloscopes, second part in the Basic Electronics 101. Stay tuned, we'll be back, and we'll see if we can get screen capture working, so that'll be a fun little bit of science there.
Yeah.
I love when there's real drama.
yes.
So I'm Chris Bowden with the Geek Group.
And,
this-
I'm Paul Kidwell.
This is Paul Kidwell, who formerly with the Geek Group, now with the American Alzheimer's Foundation. And we want to thank you guys for watching. Stay tuned in. I want to say hi to all the teachers out there and the cool classroom students that are watching these. Please remember to rate, comment, and most importantly, subscribe and donate. If you are not a member yet and you're watching this, you should be a member. Go to www.thegeekgroup.org where you can sign up for free, be a member, get involved, get hands-on with these. You could actually come down and play with our oscilloscopes here in the lab in Grand Rapids, Michigan. And you can buy, I got to tell you guys about this,
Yes,
we got them
the
now.
shirt.
You can buy nifty Geek Group t-shirts. You can buy the official professional polo shirts that we wear here on the set. You can also get other stuff like Rockstar Scientist, and there's I swear there's actually a t-shirt that one of our members submitted that says, "It's a stepper motor, yo," which is just cool. So that's become a whole thing. But when you do this, you actually help support the Geek Group, and you help us be able to make more videos and buy more oscilloscopes and reach one more kid and do one more thing, and that's what we're all about, is helping guys like you learn about this stuff. That's what's important. We want to help people get off the couch, get off the computer, and actually build stuff. So check it out, thegeekgroup.org. I'm Chris, that's Paul, that's
Paul.
Corey, and we'll see you guys next time. Thanks.
This video was made possible by a grant from the Future Girl Foundation.
This video was made possible by thousands of private donations from members and viewers like you. Please visit thegeekgroup.org for more information on how you can donate and become a part of our dreams of Avalon.